Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry the Mystery of Molecules. I believe you all are fine. So today we are going to discuss an interesting reagent, cyanuric chloride. Okay. So this is the new type of molecule. From the structure watching you can understand lots of interesting properties are there. So by the way, an interesting point I need to share that when I was a student I was a aspirant for NET exam during 2011 or 12. I didn't read this thing, but I suggest you please read this, because nowadays exam pattern became changed and became more and more difficult. So frankly speaking, if I sit at this situation, I don't know what will happen to me, because lots of new thing I need to learn. That's the reason I make this topic for you. Please read it. By the way, one another interesting request to you, please watch the video completely. It is not because of my profit I am saying, it is for you, because if you don't read the lecture properly, you miss some important point, explanation, logic, and you may just get the information, but later on you can't remember because you didn't understand, or if any tricky point come, you could not utilize. So it is better, please watch the lecture completely. If you don't have time right now, watch sometime else, but watch completely. Okay, so our today's discussion will cover few points like the basic idea about this, what is the nature of this molecule, why this is important, its preparation, and finally its use in general organic synthesis. So a lot of interesting chemistry we discussed. So let's start. As you can see, from watching this molecule, what interesting point you can learn. Okay, first interesting point is that this ring is known as triazine, or one means, if I give you proper, this is the triazine ring. Okay, means 1 3 5 means benzene 1 3 5 3 nitrogens in the benzene nucleus. Okay, means you can say tripyridine type derivative, because if you compare this with pyridine, the structure of pyridine, it will help you to remember. So if I say there is a similarity between this triazine and pyridine, you can simply understand that few points, that this is electron deficient. This is electron deficient, and if you compare this versus 4-chlorotoluene or 2-chlorotoluene, anything, we know that nucleophilic attack happens on this nucleus. Nucleophilic attack possible, but electrophilic not possible because they are electron deficient. So this much I guess fine, you already know. And this nucleophilic attack happen on SN-AR mechanism, means substitution nucleophilic internal, means nucleophile first attacks at this carbon, then it comes here, and then it comes here. Means the ultimate canonical form, if I draw, this is the minus, this is the Cl, and this is the nucleophile. Fine. So this much amount of basic knowledge you keep it will be helpful. Now let's come to some interesting point. What is the additional interesting thing for this? See, just focus on this part of this molecule. This part, or you can consider this part. What is this actually? This is actually this NCl. Just forget this NCl. Now you can compare this thing with this and we know this is actually a famous reagent, acid chloride. Okay, so this, what does it mean? That this carbon is very electron deficient. Okay, point number 1. So this thing you can electron deficient. Okay, so this is electron can attack here, or no, sorry, I should not say. So this is electrophilic, E+. That's a better thing. So this is the thing. Overall basic understand, electron deficient, this and another thing. This is actually a carbon chlorine bond. Means carbon is a second row element and chlorine is a third row element. So overlap is poor. Overlap is poor compared to compared to carbon, oxygen, nitrogen, etc. Okay, so this thing you need to give it because you have already read why acid chloride is so much reactive. Same logic is applicable for this. Okay, so this much you have understood electron deficient. So by the way, question that is it why we have made that much big or complicated molecule? Is it possible? Is it possible to make little simpler molecule? What do I mean? Simpler molecule means the same thing you can found in case of this molecule. This is known as chlorocyanogen. Okay, this is chlorocyanogen. So what is the uniqueness? So this is a good reagent from chemistry point of view because this carbon is electrophilic. Okay, and this chlorine is a good leaving group. So what we can expect? That if you put any nucleophile, it will attack, it will open up, come back, this similar like acid chloride. So what it will result? Nucleophile C triple bond M. But the biggest problem, there are few problems, not only one problem, there are few problems. So problems are, this is gaseous at RT, means around 15 degree centigrade. Around 15 degree centigrade is its boiling point. Okay, sorry, this is not 15 degree, this is 13 degree. I made mistake, 13 degree centigrade. So it is gas, room temperature, and when something is gas, it is difficult to handle. Additionally, another problem is that this is highly toxic. This is highly toxic. So, although chemistry point of view, this is a very good reagent, but this we cannot use properly because it's highly toxic. And another interesting point I taught you in my previous lecture about triazine is that if you try polymerize nitride, actually trimerize, then this CN, 3CN, you may consider in this way. Means I am saying this for your mnemonic device. It will help you to remember, but it is not that complete logic. Okay, so this like acetylene trimerization. Okay, so alternately carbon and nitrogen. Okay, so you can think that this will form a bond, this will form a bond, this will form a bond. Like simple thing, acetylene, you know. So one bond will be eliminated and it will result in this molecule. So actually this is a trimerization. This is a trimerization reaction, means trimer formation. Now what is the advantage? See, this is a gas room temperature 30 degree centigrade boiling point, but this is solid. And actually I have used this reagent in my laboratory. Generally acid chlorides are difficult to handle, but this reagent is very easier to handle. By the way, comparison, you can compare this thing as paratoluene. I am telling this information, it will help you to remember. This paratoluene sulfonyl chloride, this, or sometimes we write TSCl. Why we use always this thing? The similar interesting phenomena that this reagent is also solid at room temperature. But whereas if you take the corresponding benzene analog, that is a liquid, handling liquid is difficult than solid. So similarly, it is advantageous because it is solid. Okay, and this is gas, acid chloride is solid. So similar thing, we have understood what is the advantage. Now question, this much we have understood, the basic idea. Now how to prepare? I'll come to the property after some time. Since this is an interesting thing, so this is now, as I told, it could be prepared from the trimerization reaction of chloroacetonitride. So if I say it's a trimerization, then question obviously will come, then how cyanogen chloride is prepared? Very simple. Very simple, that if you take chlorine, means chlorine gas, plus if you react with sodium cyanide, it will result in this triazine plus sodium chloride. How? And it's a salt, so it will be precipitated out. See, this cyanide means the minus, so it attacks. We know that halogen can act as electrophile. Friedel-Crafts reaction. Remember, means not only, better to say not Friedel-Crafts. Friedel-Crafts tripe reaction means halogenation of arenes means benzene, chlorination of benzene, you can think in this way, not radical mechanism but this electrophilic. Okay, so what happens in this way, it resulted in Cl's this and sodium chloride. Okay, by the way, see, it is not that much stable also, because carbon, chlorine, same logic I put second row, third row element, this thing is there. So this is trimerization, ultimately resulted in this formation. So the basic idea we have discussed the preparation. Now we will discuss about the use of this reagent. So by the way, when I told its property similar like acid chloride, then you can consider that its application in case of organic chemistry is expected to be near about the acid chloride. Okay, so that's fine. Now question is how we can use this in organic synthesis. So first one is acid chloride formation. Acid chloride formation, one point, or this thing you can consider, or activation of carboxylic acid. This 2 point is valid, or activation of carboxylic acid. What do I mean? Because when you want to do any reaction, coupling reaction, carboxylic acid is not that much activating reagent. You need to use DCC, those kind of activator, or you can need to convert acid into acid chloride. But for that purpose, for acid to acid chloride, what we use? Reagents like thionyl chloride. But they are very drastic. And problem is that this group will be functionalized, no problem. But if you have other functional group, there is a chance that some changes will happen. That's why we need moderate and selective reagent. Okay, when reactivity is low, selectivity is high, we know. So what happens in this case? So in this case, if you look at, okay, let me draw it here. This is Cl, 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 this. Now, when you react this with carboxylic acid, means any hydroxyl derivative, I'll say, better to say, any hydroxyl derivative. So RCOOH, what it result? It attacks and it opens. What the consequence? So this nitrogen, this O. By the way, actually I make a mistake. Attack will not happen from this oxygen, rather than attack will happen on this oxygen. Okay, this is more nucleophilic. So please keep this information in mind, don't make the mistake. So ultimately, after that it will eliminate one proton, and what it will result? This OR. You know that that's why I am not going that much details. Fine. 2 left. Fine. So after that, let's consider this is the minus, this is the Cl. So in next step, what can happen? In next step, okay, so in next step it pushes and this Cl leaves. Why? So it will result in this is the Cl, this is the O, COR. Fine. And another thing, it produces the Cl minus. Why? Because aromaticity is gained. Previously aromaticity was disturbed. Now the interesting chemistry occurs. What interesting? See, right now the product is stable, I will say, because previously there was a carbon chlorine bond, so improper matching. But in this case, what it will result? It will attack here, it will come back, and this. So what it expected that it will form? So this is O minus, okay, as Cl minus attack. So along with that, what it result? R, CO, Cl, this is Cl. Okay, this. Now see, question, when it will act as a leaving group, because this charge is delocalized. How? You can check the canonical form. Canonical form is everything as it is. See, actually this nucleus is electron deficient, so this electron will be delocalized. How? O minus means this, and it will open. Okay, so it will resulting in minus stable. So here, if this is the activated acid, you can consider. So same thing is applicable for alcohol also. But interesting point, you may ask that, sir, from one acid chloride to another acid chloride you are preparing, what is the driving force for this reaction? Because previously there was a carbon chlorine, right now there is a carbon chlorine. So what is the advantage? Carboxylic acid was stable because of resonance, but this is more stable because it's a highly electron deficient nucleus. Okay, so that is the reason that this reaction proceeds. So this is actually a very good reaction for this. By the way, interesting point. At this situation, if instead of chlorine, if you put some other nucleophile, means during this course of this reaction, if you put nucleophile like some alcohol, this thing, so it will attack here and ultimately it will result in ester. Similar process. Okay, so this is the advantage of cyanuric chloride, that what it is actually doing, it is actually taking the oxygen of that carboxyl group. Because if you check the reaction, for example, RCOH plus if you take R prime OH and you want to prepare RCOO R prime, what is the byproduct? Water. Okay, so what happened in this case? This water, from this water, one hydrogen is taken by this chlorine, means this chlorine, to produce HCl with going out. Second, another OH, that OH group remain attached. Means actually I have said O minus, but in this case for ester this will be this. It will be, sorry, not 3 Cl. So this will be produced stabilized. So this is the application means it's an activator for hydroxide. Fine. Point number 1. Is there any other applications? Yes. See, after this first attack, for example, let's compare this. After the first OH attachment, some group attachment, the electron deficiency reduces. Consequently, it became little less electron deficient. Similarly, if you think like that these two, some XYZ functionalized, okay? For example, you can consider that some nitrogen thing functionalized, this, and still it is attached to this chlorine. So it will not be that much electron deficient because this nitrogen is attached to this lone pair. So such kind of thing could be used as a pesticide. Pesticide, yes. Means this is a toxin for pest, insects. Now why this is? See, after these two substitution, it is not that much deficient, but still it is at that active. Now, if you compare this reagent versus, for example, chlorobenzene, which bond, these versus this, which bond is more labile or weak? Actually, this is still weaker. So what we are actually getting? We are actually getting activated but stable, and that is the challenge. So this is stable but activated compared to this chlorobenzene. So that's why they can act as the activating reagent for this thing, means it's a pesticide. Okay. So by the way, there are some other derivatives of cyanuric chloride, like one interesting example. You please keep it in mind. This example not only here but some other case you may encounter. That is, if you hydrolyze this cyanuric chloride with water, means 3Cl will be replaced by OH and HCl will be produced. Means, for example, this with water if you treat, what will be? There will be OH, because OH will act as nucleophile, this. So plus 3 molecule of HCl. So HCl, it will go outside. It will not be in the next reaction. Fine. Now this molecule has a unique name, that is cyanuric acid. So what do I mean? It's a cyanuric acid. Means something we call acid when We call acid when it can give proton and its conjugate base is stable. Let me draw the conjugate base. So what is the structure of the conjugate base? Just remove one proton, means H plus, plus this is OH, OH, this is O minus, and these three are nitrogen. Okay, and this is resonance stabilized, I have just shown. Not only this, it can remain this molecule. So this molecule can remain in its tautomer. Tautomer means, see, it's an enol you can consider. And you need to consider the corresponding keto. So this double bond, keep 3 double bond, this is, and its contribution is significantly high. You can compare this chemistry with fluoroglycinol. You have heard, means it is a mnemonic device. In this way you can remember the story. See, if you react this fluoroglycinol, it prefers to remain in the keto form. Sorry, prefers to remain, equilibrium is preferred to remain in the keto form. This. So similarly, this is also possible. Okay, so this type of all things are possible. Now, why this is so? Sorry, I forget to mention why this is strong acidic, because the corresponding conjugate base is resonance stabilized, because 3 nitrogen pyridine. Okay, so you can remember this thing that 4 hydroxypyridine compared to phenol. This is more acidic. Similarly, like that, this is acidic. So this is the overall discussion about cyanuric chloride preparation properties and misuse. What you have learned today? We have learned about a triazine core, this ring, and attached to chlorine, which makes it a very unique as well as selective reagent. How it could be prepared from cyanogen chloride, why this is not easy to use, why this conversion is essential, we have discussed. Second, that this could be used as an activating reagent for ester, and it is activated. You can prepare acid chloride, point number 1, or you can in situ prepare ester. Because if you add the corresponding nucleophile in the reaction mixture, it will end up to final ester, amide, whatever you want. So, and additionally, that this reagent is unique because it's a very electron deficient. So, attached to this group shows some usual activity like higher acidity, keto-enol tautomerism. So, this thing. So, thank you for watching this lecture. I believe this may be helpful. Please write me in the comment box about your opinion. So if you really like my teaching, please help my channel to grow. First of all, subscribe my channel Chemistry the Mystery of Molecule. Please press the bell icon to get the notification of every single video I upload. Secondly, please share this video, like this video, and make some good comments to inspire or motivate me. Thank you again. Stay happy, stay blessed. See you in my next video.